is Emine, and I'd like to show you in this video the pH level of a lot of drinks that we have in our day-to-day lives. So I've got a number of different drinks here that I've already pre-poured for the video. We have a soft drink, a power drink, we have carbonated water here, Aquafina and Dasani, which are two well-known types of water. We've got a smart water here, and then this is tap water in this pitcher here, and in the red bottle to your right is the alkaline ionized water. So I'm going to go ahead and take pH drops. These pH drops actually allow us to see on a color chart what pH level we have for each one of these drinks. Okay, and I'm going to go ahead and mix them up. And as you can see, a lot of them are similar color. Now that's what happens there. Okay, there we go. And so we have here a pH scale, which basically 7 is a green with these drops. This is a scale. Different kinds of pH drops might have a slightly different color scale. These particular drops go from sort of a yellow on the acid side to a purple on the alkaline side. Green would be neutral, so as you go towards acid you get more and more towards the yellow side, and alkaline towards the purple. So what do we see here? Well, we see that we have a lot of yellow here, right? We've got I don't know if you can see that clearly with this white cardboard behind, but a lot of these drinks are yellow, and so they're actually on the acid side. Some slightly more acidic than others. This one is actually a slightly deeper yellow, so it's probably closer to a 3.5 or 4 on the pH scale. And then as we go along here, the power drink, the carbonated water, all of these drinks, surprisingly, you know, you'd think, hey, bottled water, I thought bottled water is actually better for you than tap water. Well, the thing is that these two bottled waters are actually demineralized waters. They're reverse osmosis, and so what that means is that they've actually removed all the mineral content, and that includes the alkalizing mineral content. And so demineralized water, distilled water, reverse osmosis water have absolutely no mineral content in them, and that's why they are acidic. This is a smart water, another kind of water, which is still on the acidic side, but you know, getting close to 7, but still on the acidic side. So this is about a 6.5 here. And then our tap water, which is this one over here, is actually very slightly alkaline. So it's not quite green, but it's going sort of a green blue. So it's just slightly on the alkaline side, about a 7.5. In this city, it might be different where you live, but basically tap water is generally right around the neutral side. In fact, in most states and provinces, the water actually by law has to be alkaline, so even if it isn't, they're going to add lye and other kinds of minerals to the water before they send it out into the municipal system to make sure that it is slightly alkaline. And well, guess what's on the right here? This is alkaline water. So we can see from the nice purple color that we actually you know, get a nice deep purple, which is right down around 9.5 on the pH scale. Now here's what's really interesting. Okay, we're going to take some alkaline water. I just want to show you what happens when I pour a little bit of this into each of these glasses. So pour a little bit in. I guess I didn't have enough drops in there because that's why it's not quite as deep in color. If I add some drops here, mix it up, you see that we're actually alkalizing some of these drinks. I'm going to put a few more pH drops because I actually put more liquid in than one normally would in the small test vial, so I guess I hadn't put enough water in, as I hadn't put enough drops in, just to see the the color. See how that turned purple right off? So just a little bit of alkaline water is actually going to turn that water alkaline. Now let's see what happens as we go along to these other drinks. Oh, look at that. Okay, well, how come that's happening? What about these guys? These ones are also not getting alkalized. How come? How come we're not getting alkalized? Here, let's pour the rest of this in here. This is like deep purple, right? I didn't have enough in my bottle. I just keep pouring it in. Nothing happens. How come? So here's the thing, okay? These are, and the pH, this color chart and these drops don't actually make a very big distinction on the acid side, and they sort of tend towards yellow because these are actually pH drops that come with ionizers, and generally you're not really testing for very acidic values for drinking water. Other pH drops sometimes go towards more orange colors when you get deeper on down onto the very acidic side. So what we're seeing here actually is that this is like very much more acidic than any of these drinks, okay? And the thing about the pH scale, okay, is it's logarithmic. What does that mean? Is that you're actually between 7 and 6, you're 10 times more acidic. But between 7 and 5, you're 100 times more acidic. And between 7 and 4, you're 1,000 times more acidic, okay? So every time you move down one number on the pH scale, you're actually multiplying by 10, multiplying by 10 again, multiplying by 10 again, and it just keeps going. That means that you're actually going to need a heck of a lot of alkaline water to neutralize just one bottle of soft drinks, okay? Soft drinks are super acidic. Do a test at home. Leave a nail in a glass of any kind of soft drink, and you'll see what happens. It's not nice. And so think about what soft drinks are actually doing inside our body. It's not a pretty picture, okay? So basically, you know, we've gone and put a bunch of alkaline water in here. Now, let's go and have a look if I take this, okay? If I go and put just one drop. Hey, I've gone and filled this up and diluted it with alkaline water, okay? But it just takes a small drop and I'm acidic again. Look at that. Incredible, no? And this is diluted, so I only had about this much soft drink, and all of this was alkaline water. But nevertheless, just takes a drop, and the acidity of these drinks down at the very acidic end of the scale will actually acidify everything. So this helps to demonstrate not only the different pH levels of these drinks, and the fact that it's sort of surprising. You don't think about bottled waters or even carbonated water. You think, oh, well, you know, carbonated water is not as bad as a soft drink. Okay, it isn't as bad as a soft drink, but it's still on the acidic side, because as soon as you put any carbonation, any CO2 into a drink, you're automatically making it more acidic. So basically this is showing not only for drinks, but basically for everything we do, how acidity can actually have a very major impact on our health, and how drinking just one bottle of soft drink, or even, you know, some things down, you know, that are not quite as acidic, you actually need to drink about 32 glasses of alkaline water to neutralize one glass of the acidic water here, or the acidic drink, when you're down at the very low end of the pH scale. So now that you've seen this, you might think twice before you reach for your next soft drink. I mean, it's a very visual depiction of how you know, the acidity works in our body, and how important it is to stay on, you know, balanced in terms of our body, but how the alkalinity is so very important to neutralize all the acidity we're exposed to, so that we can come back into pH balance. And when we're in pH balance in our body, is actually just slightly on the alkaline side, as it's designed to be. our immune system is working well, all our self-defense mechanisms are working well, and that's when we're really in a situation where we can maintain or even recover optimal health conditions so that we stay healthy for a very long time. So I hope that this demonstration was informative for you, and please check out some of our other demonstrations as well as some of our informational videos. Thanks.